Today's lesson is all about applying trigonometry. I actually don't have a copy for myself now. No, I do. Applying trigonometry and Pythagoras in 3D scenarios. Okay, let's have a look at the first question. Okay, a wooden box has the shape of a rectangular prism with dimensions 18 centimeters, 8 centimeters, and 4 centimeters. So I've drawn like a similar rectangular prism up on here. Okay, now first question: find correct to one decimal place the length of the longest pencil that can lie flat in the base of the box. So girls, from this box, let's just look at it from the top. Yeah, can you see that? Can you see the longest pencil that can lie flat inside the base of the box goes diagonally? Can you see that? Yeah, so I've drawn out that diagram on here. So what they're asking for is this diagonal length here. Yeah, and we're going to use Pythagoras to find that because I know what these two lengths are. Okay, just going back to the diagram and the numbers given in front of you, what's the length of that side? Yeah, can you see that? And what is the length of the base there? 18. So as you can see clearly then, so then x is equal to square root of 8 squared plus 18 squared, because we're looking for the hypotenuse. If you put down the calculator, it's on your answer sheet, it's 19.7. Okay? Right. Make sense? Second question. Find correct to one decimal place. Oh, sorry, I should put the segment. I even put the line there. Yeah, so that's... Hold on, let me click on that. Yeah, that's what they're asking for. That's what we just answered. Yeah, can you see that? Now, next question. Find correct to one decimal place the length of the longest diagonal of the box. Girls, in the box here, can you see that the longest diagonal that you can get inside the box is that length there? Can you see that? Yeah. Yeah? So let's look at it from the side like that. Yeah? So can you see that image here? Yeah. So let's call that length y. Okay? Now, from that image, what's the length of that? 8. Yeah, that's given. No, it's not 8, it's 4. Yeah, 4 centimeters. Yeah, that's fine. Yeah, 4 centimeters. Now, what's the length of that? 9.7. Yeah, we found that. Yeah? So as you can see now then, the longest diagonal inside the box is just a 19.7 squared plus 4 squared. And according to the answers, that's 20.1 centimeters. Okay? It's about being able to visualize 3D images. Now, next question. Find correct the nearest degree that the angle that the longest diagonal makes with the base of the box. What they're asking for in this case is that angle there, because this is the angle that makes with the base of the box. Can you see that? Yeah, so that's the longest diagonal which we just found, and that angle in between the two, that's the angle that it makes with the base of the box. Does that make sense? Yes. All right, so if I want to find that, girls, we're going to have to use trigonometry this time. What are we using? So let's just use the ones that were given here in the first place. Yeah, so this is opposite. This is adjacent. Yeah. Shh, ladies. Okay, and obviously from here, if you just shift tan that, I'll just flip over to the next page. That's 11 degrees. Okay? So this, what they're saying is that is 11 degrees. Does that make sense? Yeah. A 100-meter flagpole is observed from 2 different locations. From point A, so girls, this long line right there, that's the flagpole 100 meters. Yeah, girls, you need to really look over here. That's the flagpole 100 meters. Now, from point A, that's right here, due south of the flagpole. This is what it means. Let's look at it from the top. Girls, can you see this is the flagpole and that's due south of the flagpole? Yes. Yeah? So due south of the flagpole where that green right angle sign is, that's south of the flagpole. That's point A. That's what they're saying. So what they're saying, from point A, which is what I just said right here, if you look up to the flagpole, that angle is, what does it say it is? Angle of elevation to the top of the flagpole is? 35. So that's what they're saying. 35 degrees from point A if you look up to the flagpole. Now, second sentence, from point B, which is due east of the flagpole. So let's look at it from the top again. Can you see this is the flagpole and due east of the flagpole, that's right here? Yeah. What they're saying is from that point, if you look up to the flagpole, is 22 degrees. Do you see the difference?
Yes.
Yep. Now, find corrected nearest meter, the distance between A and B. So what they're asking is find, oops, sorry. Oh no, it's rotating by itself. Yeah. What they're asking is find the distance between those 2 points where the observers are. Yeah? Okay, so girls, here's what I'm going to do. Let's just focus on the triangle right here from point A and when we look up to the pole. Okay, so let's have a look at that triangle which I've just written up. So it's 35 degrees when you look up to the pole. We know that's 100 meters. What I'm going to do is I'm going to find out what that length is, the base. Yeah? And you'll see why. Let's do our usual. So that's 10. So that's 10, 35 is equal to 100 over x. Yeah, opposite of adjacent. If the letter is at the bottom, what do we do? 100 divided by, yeah. Yeah, remember, if the letter's at the bottom, you divide. If the letter was on top, you times across. Yeah? So if I put that in the calculator, I'm just going to do everything to the nearest whole number. So girls, this is 143 meters. Okay? Now, girls, we are going to do the same thing. We've examined that side of the triangle. Now we're going to look at it from this side of the triangle where the 22 degree is and do the same thing. So I've drawn it up here. So 22 degrees up. Yep. We still got the 100 meters flagpole. We're going to look for the base of that side of the triangle. Okay? So, once again, this is opposite. This is the adjacent. So once again, 10, 22. Yeah, let me do the working out. It's 100 over y. So y is equal to, once again, 100 divided by 10, 22, which in this case is 248 meters. Okay? Now, ladies, the reason why I need those two numbers is I've just used those two triangles to now help me link it to solve this problem now here. Girls, can you see the relevance of why I needed to find that length and that length? So I can find out that length now. Now, girls, the triangles that we examined that was on 3D can now be used to examine the triangle on the flat surface 2D. Because what we've just found is 143 here. This is the base, this is that triangle at the bottom there. And 248 here. That's what we're looking for, point A to B, which I've labeled Z. And girls, can you also see on the flat, girls, this is the important part, can you also see the triangle on the flat surface, on the flat on the ground is also a right angle triangle? Yeah? Now, without me having to actually label, I labeled that right angle, but how do you know that's a right angle in that corner there? That's because I drew it. Good. Girls, in the beginning, girls, it said point A is due south of the flagpole. Point B is due east of the flagpole. What's the angle between south and east? That's why you can assume, that's why you can assume it's 90 degrees. You need to know that because it's not always right angle, which we'll examine later on in a later topic. Okay, so we can assume it's a right angle because it's south and east. So Z is, how can I find Z now? Just use Pythagoras. Yep, so 248 squared, take away 140, oh, not take away, whoops, plus, because it's the longer side. So that's 286 meters, okay? So girls, this is how you solve 3D trigonometry questions. In order to be able to calculate 2D triangle, you get the lengths of the 3D triangles and then use those numbers back to the surface on the ground. Okay, this is the same technique that I'm going to show you with one more example because I think question 8 of the actual exercise is a good question. From point A at the base of the mountain. So girls, here's the scenario. That peak right there, that's the mountain. Okay? Now, what they're saying is from the mountain, point A at the base of the mountain, okay? The mountain peak P is due north. So what that means, girls, this is, girls, this is point A right there. Yeah? Girls, this is important. From point A, the mountain peak P is due north. So from A, if I go north, that's the base of the mountain, which takes you up to the peak of the mountain. Does that make sense? Yes. Yeah, see that wording right there is actually quite confusing. Now, and that has an angle elevation of 20 degrees. So what they're saying is, from that point A, if you look up to the peak of the mountain, that angle is 20 degrees. Make sense so far? Now, from a point B 2 kilometers due east of A. So girls, from point A, if you go east, that's 2 kilometers east. That's where point B is. And if you look at now, on the same level, the mountain peak has a bearing of 320. Girls, when it says bearing, that's not the angle that goes up. Bearing is always the angle flat on the ground. So what they're saying is, can you see that? Can you see that? Yeah, compass right there. So what they're saying is the bearing from the north until you get to the mountain, as you can see on your actual given diagram, that's 320 degrees. So don't be mixed up. Bearing is 2D, not 3D. Angle of elevation is 3D. So girls, they've given you the diagram. So let's now have a look. What is the size of angle CBA? So let me just redraw the diagram. Okay. Okay, so let me do it like this. So let me just draw C, A, B. So, girls, this is actually not a hard question. We know from here, from the diagram, all the way to that angle is 320 degrees. What they're asking for is just this bit here. Let me just color it. Yeah, that's right. Girls, we know up until here is 270. So if you do 320, take away 270, that's all they're asking for, which is, can someone do the math for me? 50 degrees, okay? So that's the first question. Now, second question. Okay, girls, this is the tricky part. So calculate the height of the mountain. So they want you to find out how high that is. Okay? So girls, here's the technique. We're going to do approach the same technique as what we did last example by examining each 3D triangle. So let's examine this triangle on the side where the angle of elevation is 20 degrees up. Yeah? We're going to do the same thing and examine that. So, let me draw it here. So this is what we're going to examine. Girls, what's this? That's what we're looking for. Yeah? That's the height of the mountain. Can you see that from the diagram? Yeah. That angle is given. That's angle of elevation, 20 degrees. Okay? Now, you know how last lesson we found an expression or a number for the base of the 3D triangle? Yes. That's what I'm going to do. Again, let's call that x. Okay? It seems very abstract because all we have is letters, but it will get us somewhere. So let's do the same thing. This is the opposite. This is adjacent. Once again, it's tan. So tan 20 is equal to h over x. And then from the previous example, girls, what did we find? The h or the x? Or the h is the ultimate goal, but to get to finding h, we needed to find x, yeah? So what did we do to find x? We divided it. Yes, yes. Yeah? We're just going to leave it like this for now. Okay? Now, let's have a look at the other side of the triangle, which is right here. Problem with that side of the triangle, girls, are we given any angle of elevation in the question? No, so we can't use that 3D triangle. So then what other triangle are we left having? The triangle on the ground. Let's have a look and see if we can somehow use the triangle I just drew here and the triangle on the ground. Okay?
It's that triangle.
Okay, let's look at the base of the triangle. Now, next, the question is, the triangle that you see over there, is it right angle? Yes. How can we assume or know that? Because in the question, yeah, it says in the question from a point B, 2 kilometers east of A. Yes, so it has to be right angle. Yes. Yeah, so this is A, this is B. What do we know? This is 2 kilometers from here.
Yes.
This is 50 degrees. Yes? Now, oh, hold on. Girls, what else do we want to find? I want to know what that is. Why? Okay, that's my next question, which you girls are already on top of. Good, exactly. Girls, the reason why I want to know that is because that side of the triangle, as you can see, is the same base as the 3D triangle standing up. Yeah, can you see that this triangle is the same as that length? Yeah, can you see that? Yes. X there, but it's also X that for that triangle. Yes. I'm so glad I made this. Yes. All right, so let's find out what X is using once again. What is it?
It's tan 50 times 2.
Good.
I said it 2 times.
So, this time, she goes, this time, X is on top. So this time I multiply across. So 2, 10, 50. Someone give me the answer for that, please.
2.3835.
So 2.4, yeah?
Yeah, 2.4.
So, girls, now that we know x, now I can replace this right there to find our ultimate goal, the height of the mountain. So that means 2.4 is equal to h over tan 20. So h is equal to, multiply it across.
0.9. Okay?
Yeah, so girls, this is 874 meters. Because in the calculator, you'll get 0.874. This is kilometers right now because we're dealing with kilometers. Yeah? But the actual question, read the question, because this is the type of stuff, girls, where you do all this work, but you don't get the full mark because you misread the question. It's just calculate the height of the mountain correct to the nearest meter. So yeah, that's how you get it. Yeah? So girls, this is a technique I want to show you with 3D trick. In order to answer 2D or 3D questions, you work with the 3D triangles and then you work your way down to the 2D triangles. Make sense? Right? Anyway, thanks girls. That's it from me. Do the rest of the exercise. This should be enough to get you the rest. Alright, thanks.